Microchip PIC16 macros by using programming language and by the compiler of pic-as. Okay, so why do we need to bother about macros? Actually, those macros, why macros? Mainly macros are very helpful if you are writing a code, for example in assembly, like this code here in assembly, and then you use the same code many times. For example, I'll give you an example. Okay, suppose you are, this is one of the drones I'm working on. Okay, like I will tell you about it later, and it uses like a microcontrollers inside. Say for example the drone is flying. Okay, if you want to have it fly upward many times, you don't have to write the code that tell it to fly upward every time you want to fly it upward, or to go right or left, or to tilt this way, or move backward or forward. What you have to do, just write that code one time, okay, and call it every time you need it. So by doing that, you save code space, what we call, or real estate, code real estate in assembly language. Adding to that, the assembly language is by itself is very powerful when it comes not only to performance, not only to speed, but to saving a lot, like a huge real estate on code area inside the microcontrollers. For example, those microcontrollers which I have from Microchip, they are all compatible. With the Curiosity. This is a Curiosity board. Okay, this Curiosity board, they are compatible. Of course, you can build your own board. It's not difficult to build a board like this one. But the thing is, you see, like all of those microcontrollers, I have tons of them. They are compatible for easy and rapid development for any system you want. For example, the drone, you are designing your own drone, okay, for whatever mission you have. Or this is a robotic motor, for example, okay, it moves the motor, it moves the robot in any direction you want. Or for example, like power supplies for various applications, okay, and you have like tons of different applications. But this is really amazing when you are operating a drone. So by using those macro codes in assembly, I love assembly. You can write them in C, okay, but I don't recommend to write them in any other language, like not even in C++ or Java for web development. It's not for, although like some embedded systems allow you to use Java, but I don't recommend to use it for those kind of sophisticated machines. Okay, I would rather use assembly language, or C, in the worst case C language, okay, especially security and other critical applications like medical, and you know what I mean. Okay, so like those kind of applications, it makes your life easier, okay, and also it saves a huge amount of code space, or what we call, some people, engineers call it code real estate. And it makes development like more understandable. And if you give this code to another engineer or developer, he or she can easily understand what you are doing, guys. Okay, so I'm trying to make it easy for you guys. Like this, this is a demo program. Okay, this is a demo program. It's working perfect. And I called it here, what I call it. I called it MP, like I called it assembly PIC16 F16 F1503 macro code macro code in assembly. Okay, it's like I called it macro example. How to use macros or subroutines. Some programmers may be more familiar with the word subroutines. People who work with database and work with Excel spreadsheet, they know what is macro, especially if they are using Visual Basic. I use Visual Basic a lot actually, but this is not close, not near at all to Visual Basic and Visual Studio and you know, macros for Excel spreadsheet. This is way different beast. This is different. It's called embedded. But Excel spreadsheet, you know, for accounting applications, for calculations, for intensive algorithms, things like that. We are not talking about Excel spreadsheet. We are talking about embedded development. This is called embedded design. To me, it's more exciting than anything else in the whole world. Okay, so let's get started now. Why using macros? Again, as I said, macros, people who use Excel spreadsheet, they are probably familiar with the word macro, especially when those who use Visual Basic, okay, with the Excel spreadsheet. Okay, macro is like a subroutine, if you wish. It's a subroutine that uses a few lines, or even maybe sometime 20, 30, or 50 lines sometime. They do certain tasks, and you can use them in your main program. So you just instead of writing the code multiple times, because every time you need them, you may use them hundreds of times. So say for example, if you want to do these tasks, the macro, the task represented by this macro, okay, this is the task. This task, what it does, it turns LED D4 and it turns off LED D6. So one LED is turned on, the other LED is turned off. So that's what this macro does. And every macro actually has different use or purpose. Okay, so now in the main, instead of writing the same code to cause the drone fly upward or downward, or to have the robot go right or left or whatever, right? You just write the macro code once and you call it from within the main many times without having to write the whole code one more time. Okay, you are saving space and headache. So this one here, actually, if you remove this thing here, now you activate the LED on. This one turns on all LEDs, but let's inhibit it right now. Okay, let's demonstrate this one after I explain to you what we are doing here. So for example, in here, those are called configuration bits. How do you obtain them? If you go to this is called the horizontal menu. If you go to the production, I believe it's production, yeah, production drop down menu, and then yeah, here you go, set configuration bits. Click on it. Okay, now you get the window that takes you for manipulating the configuration bits. For example, let's say watchdog timer. You can turn it off or on. So now it is off, but you can select to put it on. For my application, I want to turn it off, for example. Okay, this one here, like a counter, for example, or brown out reset, like here, for example, like low voltage enable. So like those, I don't have to explain about all of those things because they need like a lot of talk to explain what is going on. But for example, master clear is on. Okay, so you can turn it off, but I will keep it on. So after you select the right configurations for those what's called configuration bits, you click on generate source code to output, click on it, and now bingo. Now those configuration bits are instantly and automatically generated by MPLAB X IDE, whatever revision you have. Those codes that this IDE, integrated development environment, were generated in a way to manifest or reflect the configuration bit generation which you opted for, that adapt to your specific needs, wants in your program. Let's go back to, yeah, then after that, like you copy the whole thing here, you copy it, okay, select it all, copy it, just do copy, and then go to your main program and paste it here. Just click on right and select paste, but I already did that, so I'm not gonna do it again. Okay, because it's already pasted here. Okay, it's that simple actually. Now after that, don't forget actually to include this one here, XC for .inc. That's for Microchip PIC16 microcontrollers, and this one here, don't forget to identify in the include file for PIC16 whatever PIC chip you are using, and this is for INC include. Okay, so both they are XC.include and this one pic dot blah 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 dot include. Okay, don't forget those. Then you write your configuration bits. I show you how to do. Then now you write your macro code in assembly. Okay, so this macro code actually will set up the LEDs. It will turn them. It will set them all to output, because by default on power on they are input, but we want them to set. We want to set them as outputs. Okay, we know what we mean. Now this macro actually turns on all LEDs. Okay, by bit set file. Bit set. The first LED actually is attached to port A. Bit 5 in port A. The second LED is attached to bit 2 of port A. Okay, so we set means make high, make pin A or pin A of port A, port A, pin number 5, make it high, and set means bit set file, make high the pin on port A, bit number 2. Okay, so now we turn on those 2 bits. Okay, it's that simple. This sample macro code turns off all LEDs by bit control file, and so on. Okay, now we can flip between the LEDs, turn on one and turn off the other. And the same here, we reverse, turn off one and turn on the other. Okay, you just give it whatever name you want here. It doesn't have to be formal. Okay, just say Firas Faham macro, James Andrew macro, blah blah macro, whatever, Robert whatever macro. Okay, just write something here that gives meaning to you, that make meaning for you as a programmer. Okay, and now like we put the reset vectors. Don't forget to put this thing here. Remember that the address, memory address 0 is used for reset, for power on. Okay, and then from after that we go to setup. Okay, I will show you. This is called reset vector. And then at 0, memory address of 4, like memory address of 4 hex, this one here, that's where the interrupt vector, int underscore vector means interrupt vector. We are not using interrupt vector, but I made it a habit of mine to put it just in case I change my mind later and use interrupt but for now I'm not doing it. Just copy the whole statement here, or the whole statement for reset, copy them and paste them actually in the pic-as linker. Where do you get pic-as linker? Go to setting. Okay, go to setting, and this one here is project properties. Go down to pic-as global options, select pic-as linker and paste them here. Okay, just double click and paste them. Put the interrupt vector here and the reset vector here. Just copy from the code I gave you and paste it here. That makes your life easier. Okay, after you do that, just click on OK. But in my case, I'll click cancel, and here I'll just click cancel because I already have done that. Okay, now from reset vector, I say go to setup. So this is the setup. I set up the output as per the macro upstairs. So set output, so it does those kind of things. Okay, you should know what I'm talking about by now. Okay, set up the output. Now the main actually, what I did, I put the titles of all, like the macros upstairs, upward. So there is macro. If you go upward, if you scroll up, okay, you'll find all the macros indicated in here. one macro for LED on. It turns on all LEDs on board. So for example, those are the 4 LEDs. You have LED 1, this is this one, and this one, and this one. Okay, this one here, if you don't have it in your curiosity board, don't worry, because I put it by my hand. Okay, I soldered it by myself. I did a lot of cutting and modification in the back. Okay, but I don't have to show everything, because this by itself it needs a lot of talk, you know, like different videos. But those are the 4 LEDs. You have 1, 2, 3, and 4 LEDs. Okay, so this is the one of the PIC chip I'm using. This is the PIC16 F1503, and I have, as I said, I have many of those PIC chips that are compatible with the Curiosity board. Okay, this Curiosity board is very affordable. You can buy it from Microchip directly, or from DigiKey, or Miser, or whatever, you know, your supplier, preferred supplier. Okay, you can build your own. Actually, I have built so many boards on my own. I will show, like, I think I've shown those boards which I built myself previously, so you can watch the other videos on my YouTube channel. Okay, so now let's do this thing. Let's comment this, and there like, let's deactivate this and enable this one here. Okay, I'll just type back. By doing back, you deleted the semicolon and you activated the D4 off and D6 on. Okay, now watch, when I compile, when I click on this button here, compile, here, make and program device main project. So this downward arrow, it makes the program, it compiles it, and program this microcontroller, this one here, it programs it with the code shown in here. This is the code. Okay, so after it compiles it, it means, compiling means it transforms it into zeros and ones, or machine language. Okay, so let's just for comparison, remember that the LED that's turned on, this one that's near the potentiometer. Okay, so you have, this is the right side and this is the left side. So this on the left, extreme left, this extreme right. Watch what's gonna happen now. Okay, if I click on it, okay, it says build successful, and now I think that I hit the cable, so I have to remove the cable. I hit the cable by mistake and put it back. Okay, let's see. Okay, now let's try to click on it again. Okay, so now click again. Sometimes it does those kind of stupid things. Come on. Okay, so maybe I have to, it does happen from time to time actually. So let's try. Anyway, like, after you click on this, I think I have to restart the entire integrated development environment. This is one of the issue the MP Lab actually does have. Okay, let's see if we close all the windows, click on it again, or let's remove it again, remove it, put it back again. Okay, and let's do reset. Okay, let's try it again. Okay, apparently I have to restart this is one of, like, many people are complaining from this. Okay, put it again. Let's see. Okay, anyway, you know, it's persisting on that, so let's not fight with it. Okay, just take it on its face value, and just believe me that it does work. When you click on this one here, usually it works, but now because I hit the cable accidentally, this is now behaving very foolish, you know. So we'll give it another try, and that's it. But you got the idea actually. Like, the idea is using macros actually will allow you to do the same task multiple of times without having to write the code for that specific task. Okay, you write it only once and you call it many times. So by doing that, you keep your code well organized. You save memory space in your microcontroller, okay, and you make your life easier, and you make your code more understandable. Okay, so that's basically it, and I hope that you have got something helpful from this video. Okay, I know I have to, like, once you shut down this like MPLAB X IDE, once you shut it down and start it, it takes a while to do that. Okay, so sometimes by repeating it many times it does work, but it doesn't always work, right? So okay, let's try it again. It's yeah, like, I think Microchip company in US, located in US, they are aware of those things. They haven't solved this thing, but the IDE, their IDE is powerful. I mean, I can't complain because it's really powerful, right? It has some problems. Let's try to remove unset for a while and go to another project. Go to this one, set as main project, and then go back to this one and set. Sometimes it works. Those tricks sometimes work, sometimes they don't work. Set main project. Okay, so do that. Yeah, apparently I have to restart the whole IDE. So sorry for the inconvenience, guys, but it's really not my problem. It's Microchip, but I admit Microchip is a very powerful company. Okay, but those kind of programs, their program, it's not mine. it's theirs. It has bug, but this is very complex program. Believe me, it's amazing, wonderful, but it has some bugs in it. Okay, so like, this is the we conclude. We see that this is working actually, and we have seen the code. If we go to the main, we have seen. By the way, I'll leave you the code. I'll leave the code below, so you can copy it and paste it in your IDE. Okay, in your MPLAB IDE, and you can plug in any microcontroller here that fits, or that can adapt to this board, compatible with it, and you paste the code. You click on compile and download, then and don't forget to make changes in those statements that call the macros aboard, and you will see those macros in action. I hope you enjoy that, guys, and thank you for watching. As always, please like and subscribe. Thank you. Bye.